So what is electricity? That's what I'd like to explain in this series of lectures. So let's go back to the beginning and go back to the atom. All matter consists of atoms. For example, hydrogen, oxygen, H2O makes up water, and we are at least 70% water, so we have predominantly hydrogen atoms in our body. We know all living things contain carbon, which again is an atom. So atoms, Niels Bohr model of the atom, it's a simplified model, looks at that in the centre of the atom we have a nucleus, and it is made up of protons and neutrons. And because the protons are positive, the nucleus has a positive charge. Circulating around the nucleus are a series of electrons, and electrons are negative. And they are spinning so quickly they give us the illusion of being solid when in fact they're not. So we have a nucleus which is positive, and the outer orbit is considered to be negative. And because positive and negative attract, it keeps the atom intact and electrically neutral. So here is an atomic model. Notice the orbits or the shells of electrons that are orbiting around the nucleus. And in fact, the nucleus is so incredibly small compared to the distance to the electrons. It's absolutely, that the atoms are primarily made up of space. The nucleus is positively charged because it contains protons, which are positively charged, and neutrons, which are neutral. And each proton is made up of 3 quarks, and each neutron is made up of 3 quarks. The periodic table, going back to year 10 or year 9 science, is the group of elements that make up the universe that we know of. So everything in the universe, including yourself, is made up of these elements, a mixture of various elements. I mentioned water, H2O, carbon dioxide, which we breathe out, 40 parts per million of 40,000 parts per million of carbon dioxide with every exhalation. We have nitrogen dioxide in the air. We have all these molecules that make up the human body, and food and air, etc. So if you think about it, when the Big Bang happened about 13 billion years ago, that's when all the elements were created, which means that you're made up of elements or atoms that are 13 billion years old. And of course we know the universe doesn't create new elements, so it's already in the universe. So here's the periodic table. Some of you may have learnt the mnemonic H. Halley, Bebkanoff, Nina, McGow, Slip, Sklarka. I still remember that nearly 40 years ago. H, hydrogen, Halley, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluoride, etc. So they are the order of the first 30 elements of the periodic table. Atoms join together to form molecules. And I mentioned water, H2O, carbon dioxide, nitrogen dioxide, carbon, hydrogen, oxygen, depending on the number of hydrogen atoms in CHO, will make up your carbohydrates, sugars. So what keeps the atoms together if atoms make up everything in the universe? And it's the electromagnetic force. It's a force that exists between the positive protons in the nucleus and the negative electrons that are orbiting the nucleus. Because opposite charges attract, it keeps them together. The electromagnetic force binds atoms together in molecules. It also causes friction and attracts iron, for example, to a magnet. We call it the electromagnetism force. Now, let's have a look at carbon, for example. It was number 6 on the periodic table because it has 6 protons. The further apart the electron is from the nucleus, the less the attractive force holding them together. So you can see in this example, there is 1 electron missing, but there's 6 protons and 6 neutrons, which is in the nucleus, and there's 6 electrons orbiting the nucleus. So this is why the carbon is number 6 on the periodic table. And the electrons are attracted to the positive protons in the nucleus, which keeps that atom together. There are in fact 4 forces in the universe that we're aware of, and they are firstly the strong nuclear force, and 3 of these 4 of these forces exist in our atoms. So the first of those, strong nuclear force, is what keeps the quarks together. Remember, in the nucleus you have protons, positively charged, neutrons, neutral charged, and each of them are made up of 3 quarks. So the nuclear force that keeps the quarks together is what we call a strong nuclear force, and it's the strongest of all the forces in the universe. We then have a weak nuclear force, and this is what keeps the protons and the neutrons attracted to one another. Then we have the electromagnetic force, which we've already talked about, which keeps the protons in the nucleus and the electrons in the orbit together. And of course the last is gravity, which is considered to be the weakest of all the forces, and it mainly exerts itself on any objects with a very large mass like planets. So just to illustrate that, the first force, the strong nuclear force between the quarks, so there's 3 quarks for protons, 3 quarks for neutrons here. You can see that here. Then we have the weak nuclear force, which keeps the protons and the neutrons in the nucleus together. We then have the electromagnetic force, which keeps the electrons in the orbit and the protons in the nucleus attracted to one another, because positive and negative attract. And the last is gravity, or gravitational force, that exists in our solar system. So what is electricity? Well, we don't really know what electricity is, but we know how to use it. And roughly speaking, we know electricity is the movement of free electrons along a conductor, such as a copper wire, from a high point of energy to a low point of energy. So it's the movement of electrons along a conductor from a high point of energy to a low point of energy. So let's have a look back at the periodic table again at copper. Now copper, as we know, is 29 on the periodic table, which means it has 29 protons. 29 protons, which means it has the same 29 neutrons in the nucleus of its cell. And you can see here the electrons. There are 29 electrons scattered throughout various orbits that are surrounding the nucleus. We have, as you can see, may not be able to read it very well there, but we have 2 electrons in the inner orbit. We have 8 electrons in the second orbit, 18 electrons in the third, and only 1 electron in the distant orbit. The further away the electrons are from the nucleus, the weaker the force between them, and the more likely that electron will be lost to another atom when the circumstances become conducive to do so. The lines connecting the electrons in this example represent the forces of attraction. So you can see that in the first orbit, in the first amount of electrons here, there are 2 electrons here, that the force is really strong, and simply because the electrons are closer to the protons, so they're stronger force. In the next one, you can see that the force is actually a bit weaker because the electrons are simply further away, and the further away the electrons are from the protons, the weaker the force holding them together. So electrons in the outer orbits are much more likely to be given away by that atom than, of course, electrons closer to the nucleus. So the closer the electrons, the stronger the force. The outermost electron in the copper atom is a free electron because it is easy to dislodge. The ease at which copper atoms can give away their electrons in the outer orbit make it a really good conductor. And a conductor is a material that allows electrons to flow easily from one atom to the next. Again, a conductor is a material, normally metal, that allows electrons to flow easily from one atom to the other. So imagine this copper wire and all the copper atoms in the wire. Because the outer electron of the copper is weakly attached to the atom, the nucleus, it gives away its electrons to the next atom, which then gives away its electron to the next atom, the next, and that's how electrons flow along a conductor. And this is why we use copper as an ideal conductor wire in all your cabling, because it enables the movement of electrons to occur very, very easily. And of course we then use plastic around it, like PVC, to prevent those electrons spilling out and electrocuting ourselves. Atoms with 3 or less electrons in the outer shell or outer orbit can easily gain or lose electrons, and they generally make good conductors. So if in the outer shell of an atom they've got 3 or less electrons, like copper, which only has 1, it's more likely to give it away and therefore enable the movement of electrons. A conductor has a low resistance, which means electrons can flow freely, and most metals are good conductors, as we know. That's why we use metal in our cooking pans, because it heats the water much more quickly. You don't have put plastic on the stove, apart from the fact it melts. It's not a good conductor, it's an insulator. So we have metal cooking pans. We know our cars get really hot. They conduct heat very well, and of course movement of electrons. Most metals are good conductors, so they're used, and thus the use of copper in electrical cables and circuit boards. Going back to another example in the periodic table, we have sulfur. Sulfur is 16 on the periodic table, so it means it has 16 protons and 16 electrons. There are 6 electrons in the outer orbit, so if you look closely, we have 2 electrons. In the inner orbit here, we have 8 electrons in the middle orbit, and then we have 6 electrons in the outer orbit. Because it has more than 3 electrons in the outer orbit, it's not going to be a good conductor. It won't want to give away its electrons, which means it will probably be a good insulator because it won't conduct electricity and it won't conduct heat. More energy is required to dislodge the electrons, and that's the reason why it will be a good insulator. So an insulator is a material that does not easily allow the electrons to be transferred between atoms. Plastic is a good example. An insulator generally has high resistance to the movement of electrons. So good insulators include things like air, glass, plastic, rubber. Air is a good insulator, except during lightning storms when the voltage gets so high in the air that it can ionise the air and cause some problems, lightning strikes. So what is electricity? All properties of electricity arise from the existence of free electrons. The movement of free electrons from one atom to the other creates electricity. So when an atom loses an electron, it becomes positively charged because the electron is negative. So when you give away a negative electron, it will become positively charged. It is the movement of electrons that makes lamps light up and operates all your electrical appliances and drives the motor. For example, with an incandescent light bulb in a lamp. When the electrons move through the wire, they get through to the tungsten filament, which is in the old incandescent light bulb, you can saw it as a little squiggle. So because tungsten is a very good conductor, the friction created from the electrons moving through that little tungsten wire creates so much friction that it creates heat and light as a byproduct, and that's why it's used to create light, but also why many of your incandescent light bulbs were really hot to touch. Static electricity caused by friction, it results in the transfer of electrons from one body to another, and this is referred to as mechanical energy. A battery transfers electrons from one plate to the other by supplying chemical energy. For more information about the various electromagnetic forces, refer to this website to watch a video.